Hey everyone, this is Ron and this is a demo and a tutorial of my Blazyload library. I initially built this project about 2 months ago, and initially the main purpose for this library was to fix dependency injection. So if you want to use dependency injection, you have to register your dependencies somewhere. Normally you would do that in your main project, but if your DLL is not loaded on startup, like it's a lazy loaded DLL, then obviously you don't have any type references yet, and you cannot lazy load the specific types that you would like to register. You can do this through a workaround, like make a service locator or something, but it's quite tedious if you have a lot of types to register, and service locators are generally anti-patterns. So I created this library so that you can have both dependency injection and also have lazy loading working. So let's quickly go over the features of this project. Basically with this project, the dependencies are now registered in the libraries themselves. You can have cascade loading, so you only have to call a parent if the parent loads a lot of children. You don't need to worry about that. There's an optional wrapper, because by default Blazor won't let you return null from the app provider, even from custom app providers. You can now dynamically load any DLL. Normally Blazor will only load DLLs that are registered as lazy loaded. Technically we don't have to do that. It also enables you to load DLLs from different paths, like by default everything is dumped into a framework folder, but now you can also load assemblies from alternative paths. For example, something like framework/authenticated. If you want to create a path, for example, in your IaaS or your hosting provider, and put authenticated features in specific folders, so not all your users can load all your DLLs, but you would pre-authenticate them before you even load the DLL. Which segues into the next feature. You have now more control over how you load DLLs. You can modify the HTTP request which loads DLLs before it's sent, so you can add headers, you can add path parameters, you can change your get to a post if you want that for some reason, and so securely load your DLLs. And finally, you can load assemblies from any class, not just from the router, by injecting the Blazy assembly loader, and the router will be made aware that there are new pages and new paths, so you can preload DLL before a user clicks a path, making the user experience overall faster. So I'll illustrate the problem through a couple of demo projects. The first and simplest demo is this weatherlib 1. It has a fetch data eraser page. That page gets an iWeather resolver injected, and both the page and the resolver itself are in the same library, which is lazy loaded. Which normally wouldn't work because you wouldn't have a way to register this iWeather resolver. So to get started, you can follow the tutorial on the Microsoft page about lazy loading. My library hasn't changed that much. So if you scroll down, you can see the project configuration. They will tell you to register your assembly as lazy loaded. Technically, you can also completely leave out the project reference and the lazy load attribute. But if you do that, your library won't be compiled into your output, and you have to create manual build actions to move stuff around. So it's easier to just stick to this lazy loading approach. Then your DLLs will be moved to the right directories and stuff. So next up they tell you to go to the app.razor page, and there in the Microsoft example they inject a lazy assembly loader. When you use my library, you inject a Blazy assembly loader. And everything else is still exactly the same here. They have some extra information here as well about how to cancel on navigation events and stuff. You can follow that tutorial as well if you really want to. I haven't implemented that in my demos. So if you go into the Program.cs, you start like this. You say builder.use Blazyload, and you can either load it with config or without config. If you have very simple stuff, you don't need config. If you stick to the defaults, you don't need to use any config, though if you want to use like a custom class or a custom namespace, whatever, then you do need some config. You can add other config as well, like disable the Cascade loading feature, if you don't want that for some reason. So as you can see in the project file, I'm actually lazy loading about 7 libraries, but I'm only adding configuration for one of them, because everything else is loaded simple enough. As I mentioned in the beginning, I've added a feature to enable optional loading. You need to enable it yourself in the options by saying that resolve mode is enable optional. It's not enabled by default because I don't want to have strange behavior that you might not want. so you have to enable it yourself. The lazy assembly loader still works the same as the normal one. Basically, on navigate, you check what is the path, and then if a path is a lazyloaded DLL, we tell the lazyloader to load it. And I'll show you how to register your dependencies. You would have to create a class called BlazyBootstrap, which implements an interface BlazyBootstrap, and it needs to have exactly the signature. It needs to be a task of IEnumerable of service descriptions, which will return a service collection with stuff that you want to register. In our case, it's the weather resolver. I made this return a task in case you want to do other fancy stuff. I'm not sure what, but basically you can bootstrap anything and await it. If you don't want to await it, just retask a task result, as I'm showing you here. So this concept of putting the registrations in the libraries themselves comes from autofuck modules. This is a documentation. In the example, they do basically the same thing. You implement a module, and instead of returning a collection of services, what they do is inject the builder itself. I didn't really like that approach because it's basically a decorated pattern and it's difficult to test what your module returns. It would be easier if the module just returns its dependencies so that you can register them yourself in your builder. So in my weatherlib demo 2, I'm doing the same thing. I have a BlazyBootstrap class, only in this case I don't explicitly implement the interface, and I also don't have a reference to my Lazyload library package. So this library is completely standalone and is not aware of any Lazyload stuff. The benefit of that is that you have libraries that are independent of the cross-cutting, such as Lazyload. Of course, it makes it slightly more challenging to implement your stuff correctly, because more reflection-based magic has to happen to find your class. So if you remember from earlier, for our weatherlib3 library, I configured a custom registration class called custom registration class. The benefit of that is that you can call your class whatever you want. You don't have to call it BlazyBootstrap, you can call it whatever you want. Another thing I've added in this library is that it's conditional. So while in debug mode, it's conditional on the Lazyload library to make it simpler for myself. And the registration has a if debug. If we are in debug, we implement the interface so that we know what method to use. But then once we compile, everything Lazyload related is gone. So if you don't want a Lazyload reference in your libraries, or at least not in production, this is how I would suggest you do it. So here's the cascading load example. The layout is roughly the same. I have a weatherlib 4, which has a page, but the page references a weather resolver, which is in a different assembly in weatherlib.component, just to show you how that works. So as you can see in the router itself, I am only telling the router to load the page, and because the component of the page is not lazyloaded, but it's a reference by the page, the Blazy assembly loader understands that the page needs the component, and it not only loads the page DLL, it also loads the component DLL. So with the normal assembly loader, you have to explicitly tell it everything that you want to load. But if your project gets more and more complicated, like one project references 2 components, the 2 components refer another 2 components, and at some point you have a big spaghetti, you don't want to put your entire spaghetti in the navigation loader. You just want to reference the parent point of your whole orchestration and then pull in everything you need. That way you can set up complicated package structures without having to worry that you have to reference everything to the lazy loader, especially because you cannot do it type safely because you don't have type references in the loader. So you have to do everything through strings, which is also tedious and error prone. If you can just tell it to load the main parent and the parent does the rest, then well, it's a lot easier. So the next feature is optional dependencies. As you can see here, I'm injecting an optional of a weather resolver. Later on you see I can compare my optional with null. And even if my optional does have a weather resolver, if we check it with null, it will just say there's no servers. It might be slightly hacky, but there is no real way for the dependency resolver to return null, because Blazor doesn't play very well with the dependency resolver. Even if the resolver returns null, then a lower level component of Blazor basically checks like if dependency injection resolver returned null, throw some exception, instead of just respecting the dependency resolver. But that's Blazor things. So that's why we're doing it like this. In this weatherlib optional null library, I didn't create any registration for my iWeather resolver, and so my weather resolver will be null. In my other project, weatherlib optional not null, I did create registration, so there my optional weather resolver will not be null. So let me run this demo project and show you how everything works, and that it actually works. So let's click the first example, fetch data default. As you can see, it loads the page, it loads the weather resolver. Let me go to the network tab actually. You can see it loaded the DLL, it loads the weather resolver. Here's the custom class example, everything works fine. Here's the Cascade example. As you can now see in the network tab, it both loaded the page and the component. If we go to the fetch data with a nullable null, you can see the page still loads, but it will just say there's no weather service available because there was no registration for this weather service. And then if we go to the fetch data nullable not null, you can see the page loads and there is a weather service data here. So that way in your pages you can optionally load stuff if they are lazy loaded, because potentially they are not loaded, you don't know. And this is how you could do it. So now let's start with our second demo project, custom potting, which is something I implemented in Blazyload 1.1. So I haven't showed that yet. There's not much data about it in the README page because it's rather complicated to document everything. So I decided let's just show it in a video. That might be faster or easier to understand anyways, because this is quite complicated stuff. So as you can see in this project file, the Lazyload references are basically the same, the project references are the same. The only difference, if we scroll down, is that I've added a bunch of post-build events. So as you can see, instead of dumping everything into the default output folder of framework, I am now dumping everything into its own folder. lib1 goes into lib1 folder, lib2 into lib2, etc. The reason why you might want to do something like that is to hide features from your frontend that users don't have access to. For example, an admin panel. If you share the frontend code of your admin panel in some DLL, a hacker could potentially decompile the DLL and figure out where your backend endpoint is. So of course it's security through obscurity. You hide your backend, but if someone wants to hack your backend admin APIs, they first have to figure out where they are. For demonstration purposes, let me move this stuff into even deeper folders. So let's add everything into an authenticated folder, and let's add lib1 and lib2 into an admin folder. Another reason why you might want to do something like this is for proprietary reasons. Like imagine you have a public facing website on the public internet, but users first have to log in with their company credentials, like some kind of OAuth or whatever, before they can access your actual Blazor app. You don't really want to expose all your private internal DLLs that are only intended for authenticated users to the public internet. So if you can authenticate wall them, that would be preferable. So let me try to build this. There seem to be some issues, doesn't matter I guess. Seems like a build. So now let me show you the output on disk. We have our framework folder, inside there we have an authenticated folder. Inside there we have an admin folder and a lib3 and a lib4. Basically the benefit of this would be that if you would publish your publish build into a hosting provider like S3 or IaaS or whatever, you can set permissions based on paths. So some users would get authenticated. If the user is authenticated as an admin, he would also get lib 1 and 2. If the user is just authenticated without admin permissions, he would get lib 3 and 4. And by moving your DLLs into specific folders, you don't need to configure role permissions based on files. You would configure role permissions based on the folders that the files are in, which is much easier. So let me just delete all this stuff and undo my changes and rebuild so the files are in their intended folders again, because this part was just intended to illustrate how you would export a bunch of files to different paths. I'm not using it like that in my demo, and I don't want to reconfigure everything. So let's go to the Program.cs of this program, because the registration is more complicated than this one. As you can see here, I'm using more options. I'm saying options used for DLL, whether lib1, use a custom relative path to whether lib1. The configuration for whether lib2 is relatively the same. If the DLL is whether lib2, use a custom relative path of framework whether lib2. The only difference, as you can see here, is that I've added an extra extension, use HTTP handler, and I'm injecting a dummy handler. So if we go here into the dummy out handler, handle out, you can see in the first line or the 7th line that I've added an extra check if it's the correct assembly. It's not necessarily necessary, it's just to illustrate that you can have one handler and have different handler behaviors per assembly or per config. So what this dummy handler does, it adds a header of authorization with a bearer and a mock bearer, and also it takes the original input string, or the original input URL rather, and it appends question mark authorization is 1, 2, 3. It's not real authorization, of course, but these are two ways of how many hosting providers handle authorization. So let's go back to our Program.cs for the settings of our whether lib3. As you can see here, instead of using all the extension paths, I've just use options, which is something you can also do, which is easier if you have a lot of options. Here you can see that instead of saying use relative path, I'm saying use absolute path, and I'm pointing my absolute path to an AWS bucket. And for the authentication, I've implemented an S3 authentication handler. It's not really a production ready S3 authentication handler, because it actually expects you to provide it with the access key and the secret key of an actual EIM user. And normally in production, of course, you would not give that to your user, you would assign it a token from STS or something and handle that kind of stuff in the backend, and then just provide your user with authenticated URLs. But for this demo, I didn't really want to implement an actual backend, so this is as good as it gets. So as you can see here in the AWS auth handler, it receives a URL, it actually parses the entire URL into a host bucket in a region. Then it uses an AWS client to generate a pre-signed URL, which is a URL that has all the signing parameters in its path, and then it returns the HTTP message with the newly signed URL back to the lazyloader. If you implement a handler, you actually have to return true or false. If your handler already notices that it cannot really handle the garbage you dumped into it, you can just return false, and the lazyloader will not even attempt to load whatever you try to load. So let me show you how I've deployed this in Amazon. We go to the Amazon console, and then we go to the S3 bucket. As you can see here in my bucket, Lazyload, I've already uploaded the whether lib3 into here. In a normal scenario, you would obviously just upload your entire Blazor application into S3 and then configure permissions correctly for each folder or each DLL, whatever you want. But for this demo, I also wanted to demonstrate loading DLLs from remote locations, so I'm gonna start my application from localhost and then just load this DLL straight into it with authentication. So if we go to the permissions overview of this bucket, the bucket and the objects are not public. Block all public access to this stuff in this bucket. So you cannot access this without authentication. Let me show you that it actually works. So let me go to this WeatherLib3 DLL, which we will later try to load. So S3 tells you that the DLL is located on this location. If we just go there, you can see the file is not returned. Instead, I'm getting an error, access code access denied, which is expected because I am not authorized, even though I'm logged into the S3 console. But that's not how S3 works. You have to explicitly ask it to download, and then it will give you a download URL, which is authenticated. So let me also show you the settings in EIM, which is the user management of AWS. I've created a user here, Blazyload demo user, and as you can see here, I've added an inline permission, get object from S3, Blazyload, with the action get object, which is the minimal needed action to get stuff from S3, and from the resource bucket Blazyload. So let me launch this demo project as well. If we go to the fetch data 1, in my network tab, if I hover over this, you can see the library is now loaded from _framework/lib1 instead of just framework as configured. If I click here on the dummy out, which is fetch data 2, you can see in the request URL that DLL is loaded from framework/weatherlib2. And also you can see at the end of the URL that we've appended authorization is 123, which is the dummy out handler doing its work. Then if we go down a little bit, over here you can see in the request headers there's an authorization header, bearer is blah 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 mock out header, which is also injected by that dummy out handler. The Cascade one still works, although that doesn't really do anything impressive. It just moved both the page and the component into the lib4 folder. Let me just quickly hard refresh this to ensure I don't do anything locally. So the AWS out consists of 2 pages, the login form as you would call it, and the authenticated page itself, which contains the weather resolver again. Also, as you can see here, I've added a load DLL button because, like I mentioned, you don't actually need to use the navigator to load new pages. You can do it whenever you want. So in this demo, I'm doing it through a button so that the page is already loaded before I even hit the AWS out page path. Let's open up the console and the network again. I see Chrome already remembered my access keys and secret keys. The AWS user only has get permission, so it should be secure enough. So as you can see here, the network tab, my WeatherLib3 DLL is loaded. The AWS handler actually appended a lot of extra data, like the credentials, which is apparently my access key, together with an AWS signature, which is an encryption of my secret key or something. So now if I go into my AWS out page, you can see the page load. There is no new network event because my page is already loaded. So that's it for the demo. It went on a little longer than intended, but thanks for sticking around. If you want to try out these demo projects yourself, they are all hosted in the GitHub inside the Blazyload examples folder, so you can find them there and play around. Or you can just use these demo projects to get started. I try to cover most use cases, so you can just copy use case that's right for your project.